Good morning. We are truly excited to present our project under this year's theme, Empowering Generations, Advancing Knowledge Through Science and Education. For decades, scientific progress has built upon previous discoveries to create better solutions for humanity. Today, we continue that tradition with our innovation, hybrid UV peroxide prevulcanization of natural rubber latex with ascorbic acid as the activator. I'm Muizzuddin bin Maslan, and alongside my supervisor Dr. Sofian bin Ibrahim from Agensi Nuklear Malaysia, we've been working on revolutionizing how we process one of nature's most valuable materials, natural rubber latex. Leading our research is our supervisor, Dr. Sofian bin Ibrahim, whose expertise and vision guided this innovation from concept to reality. Working alongside him is me, Muizzuddin bin Maslan, the principal student researcher for this project, who drove the experimental work and data analysis. Our team is strengthened by our talented colleagues, Muhammad Faiz Najmi bin Mohd Fauzi and Muhammad Haikal bin Iqbal, who provided crucial support in laboratory operations and material characterization. And finally, Muhammad Amirun Afiq bin Haja Maidin, who contributed greatly to the testing and validation of our results. Let me begin with why this matters. Natural rubber latex is absolutely essential in healthcare, from examination gloves to surgical tubes and countless medical devices. However, the conventional manufacturing process has remained largely unchanged for over a century, relying on sulfur-based vulcanization. While effective for creating durable rubber, this method comes with significant drawbacks. The sulfur-based chemicals used, particularly thiorames and dithiocarbamates, remain in the final products and are well-documented causes of severe allergic reactions. We're talking about both immediate type 1 hypersensitivity that can cause anaphylaxis and delayed type 4 contact dermatitis. This isn't just a minor inconvenience, it's a serious health concern that affects healthcare workers, patients, and anyone who regularly uses latex products. Furthermore, this conventional process is energy-intensive, requiring sustained high temperatures that contribute significantly to manufacturing carbon footprints. Faced with these challenges, we asked, could we reimagine this century-old process? Could we create rubber products that are both safer for people and kinder to our planet? After extensive research, we developed our solution, hybrid UV peroxide prevulcanization. This represents a fundamental shift in approach. Instead of sulfur chemicals, we use ultraviolet light combined with organic peroxides to create the molecular structure that gives rubber its strength and elasticity. But we didn't stop there. We went further by replacing traditional chemical activators with something remarkable, ascorbic acid, commonly known as vitamin C. This isn't just an incremental improvement, it's a complete rethinking of how we can process natural rubber for the 21st century. You might be wondering, what exactly are we trying to produce? Our target is RVNRL, which stands for Radiation Vulcanized Natural Rubber Latex. Let me explain what makes this different. In traditional vulcanization, sulfur creates bridges between rubber molecules. In RVNRL, we use radiation energy to form these connections. Think of it like this: instead of using chemical glue to stick the rubber molecules together, we're using precise energy to weld them at the molecular level. This fundamental difference in approach means we completely avoid the problematic chemicals that cause allergies. The result is what the medical community has been seeking for years: a truly hypoallergenic latex that maintains all the beneficial properties of natural rubber while eliminating the health risks. This isn't just a theoretical concept, it's a proven technology that we're making more accessible and sustainable. Now, let me highlight what makes our approach particularly innovative: our use of ascorbic acid, or vitamin C in traditional systems. Chemists use accelerators like mercaptobenzothiazole or tetraethylthiram disulfide, complex names for chemicals that pose health and environmental concerns. We asked, what if we could use something safe, something biodegradable, something that our bodies actually recognize and know how to process? Ascorbic acid was the perfect candidate. It's not just safe, it's actually beneficial in biological contexts. But would it work? Through careful formulation and testing, we discovered that ascorbic acid doesn't just work, it excels. It acts as a highly efficient radical generator when combined with peroxides under UV light, initiating the cross-linking reaction effectively while being completely non-toxic. This represents a perfect marriage of performance and safety, bringing green chemistry principles to an industry that desperately needs them. To turn this vision into reality, we established 3 clear, measurable objectives. First, we needed to develop and optimize the complete hybrid system. getting the right combination of UV exposure, peroxide concentration, and mixing conditions to create a stable, processable formulation. Second, and this was crucial, we aimed to thoroughly validate ascorbic acid as a viable activator. Not just as a green alternative, but as a high-performance one that could match or exceed traditional chemicals. Third, we committed to ensuring that our final product would meet real-world demands, specifically achieving a tensile strength of at least 18 megapascals, which is the industry standard for medical-grade latex products. We weren't just creating a green product, we were creating a superior product that happens to be green. Our innovation process unfolded through 3 meticulously designed stages. In the green formulation phase, we begin with carefully characterized natural rubber latex and systematically incorporate our ingredients: stabilizers to maintain consistency, sensitizers to optimize UV response, our photo initiator to efficiently absorb light energy, and most importantly, our green activator, ascorbic acid. Each component is added under controlled conditions with specific time intervals to prevent premature coagulation. The UV vulcanization phase represents the core of our innovation. Here, the formulated latex undergoes controlled exposure to UV radiation in our specially designed reactor. A key technical insight was our ability to manipulate the mild heat, around 50 degrees Celsius, produced by the UV lamps. This heat actively assists in the decomposition of the co-sensitizer, BHPO, while the photo initiator ensures rapid radical generation upon light exposure. This powerful synergy creates a highly efficient cross-linking environment. This stands in stark contrast to traditional sulfur vulcanization, which requires sustained external heating to 70 to 80 degrees Celsius. Our hybrid system, combining targeted UV photons with optimized thermal energy, operates more efficiently and at a significantly lower temperature, representing notable energy savings. Finally, in the product validation phase, we rigorously test the resulting RVNRL. We ensure it achieves the target tensile strength, verify the complete absence of allergenic sulfur-based chemicals, and confirm the material's overall stability and performance, guaranteeing it is ready for real-world application. So, how does our innovation truly stack up against the century-old conventional method? Let's look at a direct comparison. As this table clearly shows, the differences are profound. On the critical issue of safety, we move from a high allergy risk to none, by eliminating sulfur chemicals. On sustainability, we shift from a high-temperature process to a low-energy, room-temperature one. And for the core chemistry, we replace toxic amines with non-toxic, green ascorbic acid. But the advantages don't stop at being safer and greener. Our UV-based method is inherently more adaptable. While we currently use a batch process in the lab, the technology is perfectly suited for a continuous flow system in an industrial setting, which would make it highly scalable and efficient for mass production. This opens up a world of possibilities. This safer, superior material is ideal for next-generation medical devices like surgical gloves and catheters. It can be used in sensitive consumer products like baby bottle teats. And it paves the way for future development of advanced biocompatible rubber implants. A critical question for any new material is, how does it perform against the industry standard? Here we directly compare our radiation vulcanized latex with conventional sulfur prevulcanized latex. As you can see, for fundamental properties like total solid content and viscosity, our RVNRL is fully compliant with all international manufacturing standards, proving its baseline quality. Now, let's focus on the most critical property for medical devices: tensile strength. The industry standard, ASTM D3577, requires a minimum of 24 megapascals for surgical gloves. The conventional SPNRL excels here, achieving 28 megapascals. We are proud to show that our RVNRL, produced with our green method, delivers a highly competitive 26 megapascals, comfortably exceeding the minimum requirement and proving it is strong enough for real-world medical applications. However, the most dramatic difference is not in strength, but in speed. The conventional sulfur process is a marathon, taking up to 10 hours. Our hybrid UV peroxide method is a sprint, requiring only 15 to 30 minutes. This means we can produce a medically safe, high-strength latex in a fraction of the time and energy. This combination of proven strength and radical efficiency is what makes our innovation a game-changer for a sustainable and productive rubber industry. So what have we achieved? We've successfully developed a complete hybrid vulcanization system that proves environmental responsibility and technical excellence can go hand in hand. We've demonstrated that ascorbic acid isn't just a green alternative, but a genuinely superior activator that eliminates toxicity concerns while delivering outstanding performance. Most importantly, we've created a pathway towards safer medical devices and reduced environmental impact. This work truly embodies the spirit of empowering generations. We're building on existing knowledge, adding innovative thinking, and creating solutions that will benefit both current and future generations. We're not just making rubber, we're advancing the very paradigm of how materials science can contribute to a healthier, more sustainable world. Thank you for your attention. We welcome your questions and look forward to discussing how this technology can create positive change. Muizzuddin bin Maslan and Dr. Sofian bin Ibrahim from Agensi Nuklear Malaysia.